Today you're going to extend the use of the chain rule, but first of all I'd like you to have a go at these questions. I'd like you to differentiate as many of these as you can. There are a couple that you haven't yet learnt how to differentiate. Here are the solutions. You wouldn't have been able to do these bottom two. Okay. So we're going to extend the use of the chain rule to trig functions. You can use the chain rule whenever you've got a composite function, so that's a function of a function. So we've greatly expanded the amount of functions you can differentiate compared with the Year 12 work. We like being able to differentiate because we can find rates of change, we can find minima and maxima, we can find gradients, we can find speed and acceleration if we know displacement and so on. So it's a really useful thing to be able to do. So if we're given u is 5x and y is tan of u, we can combine those to get y as a function of x. So we just replace the u in tan with the 5x and we get y is tan of 5x. Here's another example. If u is sine x and y is u squared, then y is going to be sine x all squared, which we write as sine squared x. When we're using the chain rule, we're looking at a function and we're trying to reverse that process. So here we've got y is tan of 5x. We can see that we've got tan of another function, 5x. So tan is one function and 5x is another function. So if we let the thing in the brackets be u, so 5x is going to be u, then that means y is going to be tan of u. So we split it up. Similarly, if we look at y is sine squared x, we know that means sine x in brackets squared, so we could have the thing in brackets as u, so that's sine x, and we know we need to square that, so y is u squared. You could look back at the starter questions that you couldn't differentiate yet and write them as composite functions. So you've done lots of these in the previous chain rule lessons. Just looking at this one here and this fraction, so you might have spotted that you could write the denominator as x plus 2 in brackets squared. And so then if you wrote u as x plus 2, the bracket bit, then this whole function here is u to the minus 2, and then you can use the chain rule. Okay, so the two that you couldn't do before, we've got cos squared x, which means cos x in brackets squared. So the u is the cos x, and then we square the u to get y. Here, we're fine with everything except you know how to differentiate cos of x, but not cos of 2x. So we make the 2x is like in invisible brackets, we make that u, and we've got a half of 1 minus cos u. So when we're using the chain rule, we need to first of all recognise that we've got composite functions. Try and split them up, writing y is a function of u and u is a function of x. Differentiate each bit with respect to each letter, and then simply multiply the two together. That's the chain rule. And finally, we write our answer in terms of x. So you would have had a bit in terms of u and another bit in terms of x. You need it all in terms of x. Let's have a go at this example. We've got y is sine of 3x. The bit in brackets is 3x. I'm going to set that equal to my u, and that means y is sine of u. I know how to differentiate sine of u. That, with respect to u, that's just going to be cos of u. And I know how to differentiate 3x. And then finally, the chain rule tells me I just multiply the two together. So if we do that, cos u times 3, and we replace the u with what u is, which is 3x. Okay, you have a go at this one here. You can use the formula sheet to help, and this is the answer you should get. Here's a slightly trickier one. Again, we see the bit in brackets. We're going to set that to be our u, so u is x squared minus 3x. That means that y is going to be tan of u. If I differentiate tan from my formula sheet or by memory, I get sec squared. So it's with respect to u, so we just have sec squared u. Then we can differentiate x squared minus 3x with respect to x, and we are going to apply the chain rule, which tells us to multiply the two together. If you notice that we keep the top dy is dy here, and we've got our dx is our dx over there, and the two things in between match, and it's a bit like they're cancelling. So dy by dx is going to be these two things multiplied together. And then we replace the u with what u is, which is x squared minus 3x. And there's the answer. So your turn, you have a go at this one. And this is the answer you should get. Okay, a little trickier to spot these ones. So we've got y is cos cubed x, which we know means cos x in brackets cubed. So the bit in brackets this time is cos x, and that means we've got cube of that, so y is u cubed. Let's differentiate the y. Dy by du gives us 3u squared, and now differentiate cos and we get negative sign. Okay, and the chain rule is telling us we multiply the two together, so if we do that we get 3u squared times minus sine x, and we just want to replace the u with u, which is cos x, and tidy it up a bit. And there's the answer. Right, you have a go at this one, and you should get this answer. Here are some questions for you to try. There's the formula sheet items that you get given. To help you think a bit more thoroughly about this, once you've done the first one, think about what does that mean the second one will be a bit like. Will it be a similar strategy? Will it be the look the same? Okay, see if you can predict what's coming, then have a go at the question and see if you got it right or if it gave you a surprise, and see if you can explain that. Here are the answers. Right, this is an altogether more challenging question because we have got functions within functions within functions. So we know that cos cubed of something means cos of something in brackets cubed. So let's start by doing that. So our u is going to be cos of natural log 2x, and then we just cube that for our y. Okay, now unfortunately cos of natural log 2x, we've got a function cos of another function natural log 2x. So I'm going to say that u is cos of v, and that v is natural log 2x. And again, natural log 2x is not just natural log x, so I'm going to say that 2x is equal to w, okay, and v is natural log of w. Okay, so finally 2x is a nice simple thing that we can differentiate with respect to x. So there we go, we get 2. And now if we differentiate natural log of w, we get 1 over w, which would be the same as 1 over 2x. So I can then combine these to go from dw by dx. I would like to have dv by dx. So dv by dw times dw by dx, the dw's kind of cancel using the chain rule. So we get 1 over 2x times by 2, and that cancels to be 1 over x. So I can now differentiate my u with respect to v and see what we get. So we know that when we differentiate cos, we get negative sign. So if I would like to have du by dx, then I can do du by dv times dv by dx, and the dv's kind of cancel. So I'm doing negative sine v times by 1 over x. But I can replace the v with natural log 2x. So let's do that. There we go, and now we have du by dx. Right, so finally we're getting to our y. So if we differentiate y with respect to u, we get 3u squared, and then we can apply the chain rule and get dy by du times du by dx will give us finally dy by dx. So this is what we get first of all, and I can replace the u with cos of natural log 2x and tidy up slightly, and there is the answer. And we breathe a massive sigh of relief. That was a big palaver. So here you go. You have a go. There's one that's a tiny, tiny bit simpler, but not much. It's still hard. Okay, here is the answer. You just have to be super systematic so you don't lose track of anything. Okay, here's a lot of practice questions for you. Okay, good luck with those. Here are the solutions. And here are some problem questions. Just remembering, so this one here, number 9, combines what you've learnt about the chain rule with what you know about mechanics and equations of motion. You know that when you start with displacement, you differentiate to get velocity, and you differentiate again to get acceleration. Exact coordinates for question 11, so you must work with fractions and roots and pi and things like that, and not with decimals. Stationary points are when the gradient is equal to 0. Question 14, straightforward differentiation to begin, but then you have an equation to solve. That will be a trig equation to solve, but hopefully you're now experts on that. Okay, here are the solutions. So you've now looked at lots of different examples of the chain rule. So if some of these will become automatic to you when you're doing lots of practice of them. So that's super. If you can do the simple ones in your head, that's great. The more complicated ones where you've got functions of functions of functions, you need to be more careful and systematic about. If this never becomes automatic, it doesn't matter, because you can always write down 1 as a function of u and u as a function of x, differentiate both of those and multiply. Okay, so here are the familiar ones that you'll come across a lot. Here are the familiar ones that you'll come across a lot. So u is u to the power of n. We should have n times the derivative times u to the n minus 1. There's a missing n there, apologies. E to the u, differentiate the u times e to the u. Natural log u, differentiate the u, put it over u. Sine or any trig function of u, differentiate the u and multiply by the derivative of the trig function. I've used sine as an example here, but you could have any trig function. Okay, you might see these in this format where we have y is a function of x to a power, or e to a power of a function of x, and so on. It's just a different format. Here's a final challenge. So you need to be able to tell when you can use the chain rule, okay, and when you can't. So have a go and see if you can split these up into ones that you could use the chain rule for, and ones where you can't, and ones where you just have something basic. Okay, so for this here, you can see that we've got one here that would simplify to be a basic, because sec is 1 over cos, and 1 over cos times sine gives us tan x, and we know that basic rule. And in fact, this one here should also be in the basic section, because sec times cos just gives us 1. So that one really should be over here in the green box. But the rest of these, you can see that we can use some trig identities to simplify matters. But you also know about powers. E to the power of sine x times e to the cos 3x is the same as e to the sine x plus cos 3x, and that means you can use the chain rule. Same with the division, gives you a subtraction in the powers, so you can use the chain rule. We've got a log of two things multiplied together, which splits into a sum of logs, and you can apply the chain rule. And then we have more obvious uses of the chain rule. And here, these ones we can't use the chain rule for. Let's look at the trig ones. So we don't have any trig identities that are going to simplify these. Okay? And we don't have a function of a function, what we do here, but it's multiplied by another function. So we've got two functions multiplied together, and you haven't learned how to deal with that yet. You need a new rule called the product rule for that. The same here, we've got x times by e to the sine x. We know we could use the chain rule for e to the sine x, but when we've multiplied by an x, we now have a product. You don't have a rule yet for that. Okay, here we have a division, And here we have a division, and you haven't learned a rule for doing one function divided by another, only a function of a function. So we use chain rule for composite functions, functions of functions, and we need new rules for other ones, and you'll learn those next. Well done, and that's it for today.